All right, picking up at number 5 on the back side of this worksheet, just want to mention that I did do number 3 wrong. I had ordered those originally from least to greatest, getting the answer of A. I did that backwards. It should be from greatest to least. Convert everything to a decimal and put those in order. The correct answer was C. Now on number 5, which list orders the numbers from least to greatest? Smallest number to the largest number. Now, these are all different, so you'll have to go through them one at a time. I've got negative 1.4, and then a positive 75%, and then a negative 1/2. If I'm going from least to greatest, I cannot switch from negative to positive and then back to negative, so A will not work. On B, I've got 0.65. Looks like all of those are positive, so I'm going to convert those to decimals. 0.65 is fine, and then 8 divided by 9 is 0.8 repeating. 15 divided by 3 is a whole number 5, and then I've got 5.12, and then I've got 80%, which is 0.8. Now, if I'm going from least to greatest, it should not make sense to you that 5 and 5.12 would be lower on that list than 0.80. That one is incorrect. We actually needed this 80% to be here. Got to remember to convert those to decimals. On C, I've got negative 5 over 9, negative 2, 0, 25%, and 2.22. As far as positive and negatives go, those are okay. But if you look, you've got negative 5 over 9, which is less than 1, and then you have negative 2. With negative numbers, you're thinking distance from 0. Negative 2 is farther away from 0, which makes it the smaller number. So these two needed to switch places. On D, we've got negative 10, negative 16 over 15, which is going to be a negative 1 point something. Then we've got 1/2, which is positive, 100%, which is whole number 1, and then 5.3. So everything on that one is perfectly okay. Number 6. Which number can go in the empty space? So the numbers are arranged from least to greatest. We want to go from smallest to biggest. We've got negative 2, negative 7/8, 1 3/5, which as a decimal is 1.6. So we need to be between 1.6 and 2. 1.3 is too small. 1.20 is too small. 5 divided by 3 is 1.6 repeating, which looks to be okay. And then, of course, 9 over 4 is 2 point something, which is going to be greater than 2, which eliminates it as well. The answer here is D. Number 7, of the numbers 1/8, 13%, 0.1275, and 0.12 repeating, which number is the least? Which number is the smallest? 1/8 you need to convert, and it is 0.125. That's 1/8. 13% is 0.13, and then you've got your 0.1275 with a repeating 5 and 0.12 repeating. Now we want the least number. These are all positive. We're going to have to look at the second decimal place. 1/3 is bigger than 1/2, so we can eliminate it. Then we will look, we've got, this one would be 1/2 if we carried that on out. So looking at the third decimal place, we have a 5, a 7, and a 2. The smallest one would be the 0.2. Number 8. Of the numbers 17, 25ths, 67%, 0.6725, and 0.6 repeating, which is the greatest? This time they want to know which number is the biggest. We've got 17 over 25 which is 0.68. 67% is 0.67. Then I have 0.6725 and 0.6 repeating, which would be 6 going on forever. Now we want to know which one is the biggest. The first decimal place is the same. And then on the second decimal place, we have 6778. The largest one would be the 8, which means 17 over 25 is the greatest. Number 9. Which of the following rational numbers is closest to 0 on the number line? Now, they don't want least, they don't want greatest, they want to know closest to 0. Again, I would convert these. Negative 2 over 5 would be negative 0.40. Then you've got negative 0.875. 2% would be 0.02. And then 0.5. We're talking distance from 0, so we're really talking absolute value. We want to know which one is the closest. We've got 0.4, 0.8, 0, and 0.5. Now, the closest to 0 is going to be the 0.02. Number 10. Which of the following rational numbers is the farthest from 0 on the number line? We've got 12.5%, which sounds big, but when you convert it to a decimal, it is 0.125. Negative 1/3 would be negative 0.3 repeating. And then, of course, the 0.16, if you extended it, would just, the 6's would keep going. And then the negative 0.25. Now, we are talking distance from 0, so again, absolute value, you get to ignore the negatives. Which one is the farthest away? 0.1, 0.3, 0.1, or 0.2? Farthest away is going to be that negative 1/3. Okay, none of them are far, but that one would be the farthest. In your practice book on page 23, the example problem is reminding you how to turn a fraction into a decimal by hand. You should remember this. You just divide the numerator by the denominator, and they're showing you what a repeating decimal looks like. Okay, you should always look through the examples. Number 1, Erica says that no matter how many decimal places she divides to, when she divides 1 by 3, the digit 3 in the quotient will just keep repeating. Is she correct? Explain. She is correct. Look at her work. She set it up 1 divided by 3, and she keeps getting this 3. Well, the reason she keeps getting 3 is because she has to make it a 10. Well, when she divides 10 by 3, it only goes 3 times, and that's a 9, which leaves her that remainder of 1. And then she's right back to where she started. The process just keeps repeating over and over and over because the remainder is the same every time. Okay, lots of acceptable explanations here. Number 2. Is the decimal for 4/3 a repeating decimal? Guys, if you look at 4/3, you should notice that the denominator is the same as 1/3. But if you made this a mixed number, 4/3 is equal to 1 and 1/3. Well, that means if you was to make this a decimal, you would have 1 point and then the 1 divided by 3, which is going to give you that repeating decimal again. Okay, 1 and 1/3 is the same as 1/3. It's just got a whole number in there with it. So, yes, it is a repeating decimal. Number 3. How could Erica have used the decimal that she wrote for 1/3 to find the decimal for 2/3? Well, if you notice that 1/3 times 2 would equal 2/3, then you would know that she could have took her decimal, 0.3 repeating, multiplied that by 2, And she could have got 2/3 at 0.66 repeating. If you double one, you could double the other version because the numbers are the same. Number 4, write the decimal for 1/8 and explain why the decimal is called a terminating decimal. Now, if you had a calculator handy, you probably just divided 1 by 8. If you did it by hand, you're going to divide 1 by 8. It will not go, so we add the decimal and a 0. 8 does go into 10 one time, and when we subtract, we have 2 left over. We'll put another 0 and bring it down. Now we've got 20 divided by 8, which goes 2 times. 2 times 8 is 16, left us with a remainder of 4. We'll put another 0 on there. 40 divided by 8 is 5. 5 times 8 is 40, so there is no remainder. So why is the decimal called a terminating decimal? It ended evenly with no remainder. Okay. Once you run out of remainder, the division stops. There's nothing else you can do there. Number 5, tell whether each statement below is true or false. If it is false, write an example that proves the statement is false. All fractions can be written as repeating decimals. We know that is false. And we know that is false because we now know that irrational numbers exist. Okay, irrational numbers make this false. Irrational numbers like 1/8 we just said does terminate.
Yeah, so
I had an example in the last class. What did we use? I can't remember. When I remember, I will write it down for you. I went a blank. If a fraction can be written as a repeating decimal, only one digit can repeat over and over without end. That is false. You should also know that any amount of digits could repeat. You could have 0.262626. Okay, that would be a repeating decimal, and you would be repeating more than one digit. Oh, I don't remember. Irrational numbers, and then we had those terminating decimals. We did 2/5, which came out to 0.4 because it had an end. Sorry, I went blank on that one. Number 6, Raj is playing a game. He needs to find pairs of cards that have the same value. Which 2 pairs of cards does Raj have that express the same value? We have decimals, we have fractions. We need to convert those to the same form. If I divide 7 by 9, I get 0.7 repeating. 3 divided by 8 gives me 0.375. And then 3 divided by 5 is 0.6. I'm looking for matching pairs. 0.7 repeating and 0.7 repeating would be one pair. And then the 0.375 and the 0.375 would be the second pair. So that would be your pairs of matching cards. All right, number 7, we're just putting these on the number line where they belong. I've got 0 here. My negative numbers are going to go to the left of 0. Okay, we have 2 of those, 2 negative numbers, and I have 2 negative options up here. Negative 2.8 is between negative 2 and negative 3, so it goes here. Negative 13 over 9 is 1 point something, so it's going to go in this box between 1 and 2. Now my positive numbers, there's 4 of those. This one is 2.16, which means it's greater than 2. I'm going to put it here. And I've got 1.78, or I'm sorry, 1 and 7/8, which will go between 1 and 2. And then between 2/3 and 0.25, 2/3 is 0.6.